Hi, my name is Milan, and in today's video we're going to discuss the driving principles behind clean architecture. We're going to talk about cohesion, separation of concerns, the dependency rule, and how all of this helps us build a testable and maintainable system. We're also going to tie this into the vertical slice architecture and see how we can combine the benefits of both of these architectural approaches. I'm going to start from an empty .NET 8 Web API. The only things I have configured are code styles inside of my editor config and a few solution level settings inside of directory build props. All of my projects will target .NET 8. I'm going to enable implicit usings and nullable reference types. Then I'm configuring some settings when it comes to code analysis. The most important one is that I want to treat warnings as errors. And I'm also installing the Sonar Analyzer C# NuGet package, which introduces some additional static code analyzers. This is all of the boilerplate that I'll need. And let's start our discussion about clean architecture by defining our first use case. I'm going to define a folder that's going to contain all of the use cases related to the user entity, and I will call it users. And inside of it, let's start by creating our first use case. Let's call this the register user use case. And this use case should contain all of the logic that is required for a user to register with our system. Now, the obvious problem that we run into is that we don't have a user entity. So let's go ahead and fix that. And I'm going to start from a completely anemic entity with just basic properties. So I'm going to assign a GUID as the identifier of my user. This is how I'll be able to uniquely identify it. Then I'm going to give each user an email and two more string properties. Let's call this the first name and the last name. So just basic properties on the user. And then let's also store a password hash. This is going to be the hash password of the user when they are registering with our system. So we have our entity. Now we need to implement our use case. So let's define a handle method that's going to contain the logic for this use case. And let's say that this method should return a user once we create it. Let's call this method handle. And what are some steps that we need to have in order to register a new user? Well, the first and obvious step would be creating a user and then possibly storing that user inside of the database. So let's first implement these basic steps, and then we're going to discuss some additional behavior that we want to have inside of this use case. In order to create a user, we need to have some input information. And to be able to achieve this, I'm going to define a record that's going to represent my request object for this use case. As far as the values on this record, let's define an email, a first name, a last name, and of course a password. We're going to use this request as the argument for the handle method, and then we can go ahead and implement the first step, which is creating a user. So let's just new up a user instance, and we have to assign these properties one by one. We can generate a new identifier. Then for the email and all of the other properties, we can just assign them from the request object. So let's go ahead and do that. For the password hash, we would need to hash the input password. So let's deal with this in just a moment. I'm going to leave a question mark here. And then let's go ahead and return this user from this method, essentially satisfying the method signature. Of course, we still have to implement this step here, which is actually storing the user in the database so that we actually persist the user's information for future requests. And to be able to achieve this, we need a way to interface with our database. Now, when you follow clean architecture principles and we need to interact with an external facing service, such as a database, but this could also be an email service, a file system, or anything else, we need to define a respective abstraction. So let's go ahead and define such an abstraction. I'm going to create an interface that I will call the iUser repository. So this is going to represent our abstraction for talking with the database. So let's define a method that we can use to create a user. It's going to be an async method. I will call it insert, and it's going to accept a user argument. And then what I have to do is to inject the user repository inside of my use case, and I can use it in the handle method. So I can say await user repository insert and pass in the user instance. And the repository will take care of persisting the user inside of the database, essentially hiding all of the communication details with the database inside of the respective implementation of this abstraction. Now let's do a context switch and briefly discuss the clean architecture on a high level. This is a very common representation of the clean architecture where we have the domain layer at the core, the application layer surrounding it, which contains your use cases, and we have the infrastructure and presentation layers containing the implementations of the abstractions in the levels below. So fundamentally, we have our domain layer at the core that contains our system's entities. In our example, this would be a user. In the application layer, we have our use cases that contain the functionalities of our system, like the register user use case. In the presentation layer, we would define an API endpoint to expose our use case to the outside world. And then in the infrastructure layer, we would encapsulate any implementations talking to the database or any other external concerns. So each of these layers have their own responsibilities, and in general, it's not uncommon to have the application and the domain as a single layer representing the application core, and you can also even merge together the presentation and the infrastructure layer into one project. The main thing we have to respect with regards to clean architecture is the so-called dependency rule. The dependency rule states that all of our source code dependencies should point inwards. In other words, the domain layer shouldn't have any references because it's at the core. The application layer is allowed to reference the application, and the presentation and infrastructure layers are allowed to reference the layers below, which are both application and the domain layers. Another way to look at this in the context of our registered user use case is we would have the user sitting at the bottom, then we would have our use case one layer above, being able to reference the user. Now, because the use case needs a way to interface with the database, we define an abstraction, which is the user repository, which is implemented by the infrastructure layer. And at the top, we have our endpoint that needs to be able to reference our use case in order to expose it to the outside world. Now, a big pushback that I've heard against clean architecture is that it produces a solution with many layers of abstraction, where typically we would have a separate project for each of the clean architecture layers and also organizing around technical concerns, which reduces the cohesion of our system. So let's see if we can address both of these points in our implementation. If you keep the previous diagram in the back of your mind, the only thing we have to respect here is the dependency rule. We want our use case to be able to reference the user entity and also to interface with the database, which we achieve using an abstraction. And as you can see, we don't necessarily need to have separate projects in our solution in order to achieve this structure. We just have to respect the dependency rule in our source code. Now, this becomes problematic when teams don't want to follow these principles, and this is why most clean architecture templates already come with multiple projects inside, but it's definitely not the only way to organize your solution. So let's go ahead and move these classes into their own files, and keep in mind that they are all still going to be inside of the same folder. So everything related to this use case is defined in one place, which means that the cohesion between these components is very high. Now let's go back to our use case and add the missing steps. First of all, we have to decide how we're going to hash the incoming password. Well, for this, we would need another abstraction. So let's go ahead and create an interface. I'm going to call this the iPassword hasher, and it's going to have just one method called hash, accepting a string argument that's going to be our actual password, and it's going to return another string representing the hashed password. So let's go ahead and inject this through the constructor, and I like using the primary constructor feature inside of my use cases because it makes my classes more concise, and I'm really not concerned with the fact that these are parameters and you can assign values to them. Nobody's going to do that. So let's go ahead and call the hash method, pass in our password, and here we have our password hash. All I'm doing so far is implementing the logic inside of my use case by just defining the abstractions that I need in order to achieve all of this. Now let's expand on this after creating and storing the user in the database, and we also managed to create a password hash. We need to implement a business rule that user emails have to be unique. So we can go ahead and do something like this. I'm going to say user repository exists. Let's say I pass in the email from the request. And if this method that doesn't exist yet returns true, I'm going to throw an exception. You could also return a result or an error object here. I talked about this in some of my previous videos, but the general principle is to fail fast and just return from this method as soon as we have an error condition. So let's say I write a message that the email is already in use. And of course, we have to define this method on the user repository. It's going to be an async method returning a boolean, and it's going to accept the email as the argument. And if I go back to my use case, then everything is still compiling. A few more things I might want to do inside of this use case is implement email verification for the user that is registering with our system. And we also might want to generate an access token and return that instead of returning the user object. In this case, I'm returning the user just as an example. Also, I'm noting that using an anemic domain model is completely fine. We don't have to force any logic or domain-driven design principles into our system at the very beginning. And even though clean architecture has the domain at the core, it doesn't mean that you have to use domain-driven design. This is another common misconception when it comes to clean architecture and domain-driven design principles. Another issue that we might have with this implementation is the possibility for a race condition. If we have concurrent requests checking if the email is available, they could both succeed on this check and then proceed to create a user and insert that into the database. At this point, we would have an invalid state in the database. So there are two ways how you could solve this. One approach would be to introduce a lock before beginning the handle method, which would reduce the concurrency of your system. Another approach could be to define a unique index inside of the database, which is something that I prefer, and we could encapsulate this logic in the user repository. So if we do get into a situation where concurrent requests try to insert a user into the database, the unique index in the database is going to keep us safe. All we would have to do is to handle the respective exception for one of those requests, because they can't both insert the same email into the database. And for the request that encounters an exception, we could return our respective error to the user. What I like about clean architecture and organizing around use cases is that you can essentially achieve vertical slicing. The register user use case represents one vertical slice inside of our system. We're also respecting the explicit dependencies principle by defining all of our dependencies in the constructor, and because we are depending on interfaces, our use case is highly testable. Now at this point, we don't have code that's runnable because we don't have the respective implementations of these interfaces, and we also didn't expose our use case inside of an endpoint. But if we go ahead and build this project, you will see that it compiles. And at this point, I'm ready to write tests for my use case where I can verify if the behavior I have inside is correct. Now what you could do here is to write your tests manually, but you can also use an AI coding assistant to write the test for you. I've used Copilot and Amazon Code Whisperer in the past, which can both be integrated into Visual Studio, but you can even use something like ChatGPT or Google's Gemini. Here's a prompt that I sent to Gemini, which only contains the code for my use case, and my prompt was to generate an exhaustive set of unit tests using XUnit and substitute for mocking and fluent assertions for the assertions. I also want to organize my unit tests in the arrange act assert format, and this is what Gemini generated for me. So I'm going to copy this code, and then let's see if we can paste this into Visual Studio and confirm the behavior of our use case. I'm going to quickly add an empty unit testing project. So let's add a new project. I'm going to choose XUnit test project, and let's just call it unit tests. In place of the existing unit test class, I'm going to paste what Gemini generated for me, and let me just reorganize the using statements correctly. And the only thing that we are missing is a reference to our use case. So I can go ahead and reference the web API project, which should let me see the use case and my user repository and password hasher abstractions. Now at this point, I'm missing some NuGet packages. So let's go ahead and install and substitute. I'm going to install the latest version, and let's also add fluent assertions. With the latest version installed, let's go back to our test, and it seems like everything is compiling. I only have a remark here that I should use an explicit type, and let's also update the name of our file to match the test name. Now, before exploring these test cases, let's see if they actually execute. So I'm going to run both of these tests, and you can see that both of our tests are passing. Now let's take a look at what we actually have here. So we first have the two substitutes for the two dependencies that we have in the register user use case. In the constructor of the test case, we are creating a new instance of the use case and passing in the mocked instances of the user repository and password hasher. And then we have our first test case, which is called handle with unique email, creates and inserts user. And I even like the naming convention here. In the arrange step, we're creating a new request object, configuring our two mocks. Then in the act step, we are just executing the handle method. And in the assert step, you can see that it's verifying the structure of the user result, which is returned from the handle method. And it's also confirming that the user repository received one call to the insert method for this object. Now let's rename this to user because I think it's more descriptive of what the response type is. And then let's take a look at the second test case. So this one is called handle with duplicate email throws exception. So it's figuring out that we are throwing an exception and trying to write a test case for that. It's creating another request object, configuring the user repository exists method to return true. Then for the act step, it's actually wrapping the execution of the handler or the use case inside of a function, which is great because this is how Fluent Assertions allows us to test for exceptions. And then it's saying act should throw some exception with this exact message. And this is precisely what we are specifying in the use case. It's also checking that the user repository didn't receive a call to the insert method. So let's see if I can break these tests by specifying false here and specifying 1, 2, 3 in the configuration for the password hasher. So let's run our two test cases, and I'm expecting both of them to fail, and this is exactly what happens. So let's go ahead and revert this to the previous behavior and make sure that our tests are working. So whenever you have unit tests, you also want to make sure that you can break the logic that's inside. So this is how you can implement your first clean architecture use case completely from scratch, verify it with unit tests, without actually having to implement any of these abstractions. Now you can go ahead and provide an implementation for the user repository and the password hasher, and then we would be able to persist the user inside of our database or any other persistence store that we want to use, along with a proper hash for the specified password. Now a few things that are missing here are input validation for the request object, some validation for the password strength. These are all things that we could implement inside of this use case, but I'm going to leave that as a homework assignment for you. If you want to see how to add validation to your clean architecture use cases, then you should watch this video next. Check out my clean architecture and modular monolith courses to improve your skills, and until next time, stay awesome.